Hi all, I'm Madam Kong. This is my third video to discuss about the electrochemistry topic. So for this topic, there are 5 questions for paper 1 and 10% for paper 2. So let's start our revision by using 4 latest PSPM questions. So we start with our first set. Okay, this is the original question. Let's analyze the question. Consider the cell notation below for a galvanic cell at standard condition. What means by standard condition? Means 1 atm, 25 degrees Celsius. Okay, so this is cell notation. You have to be very clear. When a cell notation is given, the early part is anode, and then followed by cathode. So the phase division, okay, and then here salt bridge. Question asks about write the half reaction that occur at both electrode. So means for the anode and cathode. This is simple question. Okay, number 2, calculate E cell for the electrochemical system. So E cell means not at standard condition. Normally we are going to apply Nernst equation. And then the standard reduction potential for iron and zinc were given. Okay, so write the half cell. So anode, zinc undergo oxidation, become zinc 2 plus. And then cathode, iron 2 plus aqueous undergo reaction, become iron solid. So I have to write out the whole equation. Combine the anode and cathode. This is the overall equation. So calculate E cell. Okay, before we proceed, we must know what is the formula for Nernst equation. So E cell equal to E node cell minus 0.0592 over N log concentration of product over concentration of reactant. So how to find the E cell, E node cell? The E node cell we have to find from this formula. E node cathode minus E node anode. So between these two, which one is anode? Which one is cathode? So iron is cathode. So cathode, the value is positive 0.44 volt. Okay, minus cathode. Cathode is negative 0.76. So the E node cell is 1.20 volt. Always remember the positive negative sign insists. Okay, next, what is the value of N? N is referred to the number of electrons. So based on the anode cathode equation, we notice the number of electrons is 2. And then log Q, Q is concentration of product, here product, over the concentration of reactant here. Zinc solid and iron solid ignore, because if you still remember for the Q, okay, in chapter 6 XK015, we ignore liquid and solid. So then you substitute all the value. Then you get the answer, which is positive 1.22 volt. Okay, next, let's discuss PSPM set 2016-2017. Okay, this is the original question. Okay, let's analyze the question. A galvanic cell is constructed by connecting a nickel plate that was immersed into 1.5 molar nickel nitrate solution and an aluminium plate that was immersed into a solution containing X molar of aluminium 3 plus iron. Okay, so based on this question, galvanic cell, we have to remember cathode positive, anode negative for galvanic cell. Okay, if the cell voltage is 1.4 volt, cell voltage is referred to E cell. Number 1, calculate the standard cell potential. Standard cell potential is E node cell. So normally this one we will apply the formula E node cathode minus E node anode. Okay, and then 2, determine the value of X. Okay, based on this question, the question didn't give the instruction for you all to write down the anode and cathode equation, but it's a must for you to write down the anode and cathode equation in order to help you to answer the question. Remember, must write down both anode and cathode equation. B, electroplating is one of the techniques used as a protective coating for metal. A student is requested to electroplate the iron nail with tin. If a current is passed through the electroplating solution, write the half cell equation at the anode and cathode. Predict what will happen, okay, for both terminal. So in this case, you must know what is the symbol for nail. right? Iron nail with tin. Okay, so with tin. Okay, so meaning that it's coated with tin. So what's the symbol for tin? Let's check the answer. Yes. Okay, the symbol for tin is SN. Okay, this is what I said before. You have to write out the anode and cathode equation, even though the question didn't ask you to write down. Aluminium undergo oxidation, become aluminium 3+, nickel undergo reduction, become nickel. So this is the overall equation. So first question asks you to calculate the standard cell potential. So you just apply this formula and then write down the half cell for each standard reduction potential. So this is half cell for nickel, this is half cell for aluminium. Substitute the value, you get the answer, positive 1.41 volt. Remember the sign insists and then the unit insists. If not right, you won't get this 1 mark for the final answer. Next, the question asks, okay, need to find out the concentration of aluminium 3+. So in order to find out this, right, you must write down the Nernst equation, and then what is the value for E cell given? What is the final answer for E cell? Okay, calculate just now for part A. And then what is the N value from here? That's why must write down the anode and cathode equation. So the N is equal to 6. Okay, what is the concentration of product? Here, concentration of aluminium to the power of 2. So again, you must combine both anode and cathode equation in order to get the overall equation. Anything that involves Nernst equation, you must write down anode equation, cathode equation, and overall equation. So product over reactant. Reactant is nickel. Nickel 2+ to the power of 3. Solid, solid, just ignore. So after you substitute everything, right? Again. Make sure you know how to press the calculator and get the value of X, and have to write down X actually is equal to the concentration of aluminium 3+, which is 5.9 molar. Final unit insists. Okay, next. Tin is Sn. So for both equations involve Sn. Anode undergo oxidation, Sn become Sn2+, cathode undergo reduction, Sn2+ become Sn solid. That's why for anode, the mass of anode will be decreased or become thinner because all dissolved become Sn2+. And the mass of cathode sure will increase or become thicker because the Sn2+ deposited become Sn solid. So clear? Next at PSPM, set 2017-2018. Okay, this is the original question. Let's analyze this short question. An aqueous solution of lead nitrate. So lead nitrate, you must know how to write out the molecular formula. Lead is silver, Ag. Nitrate is NO3. Was electrolytes using a current of 2.0 ampere for 30 minutes. From here, right, this first information, you automatically will think you need to apply Q equal to IT and then find out the column. So determine the volume of gas evolved at anode. Okay, at room temperature. The molar volume of room temperature is 24. Anode, what happened? Normally for anode, right, water will be chosen if compared to NO3. So water will oxidize, become oxygen. So let's check the answer. Okay, so first of all, right, this question is related with Faraday law. So the first part, you must write out the formula Q equal to IT. So the I 2 ampere and then the T is 30 minutes. Always remember the T mass in seconds. So that's why you need to times 60. So the answer is 2600 coulomb based on the current given. So in general, you know that 96,500 coulomb is equivalent to 1 mole electron, equivalent to 1 Faraday. Based on the calculation just now, is 3,600 coulomb. So from here you can check what is the number of mole of electron or what is the Faraday produced based on this current, this amount of current. So this, okay, then continue. So the question asks about, okay, anode, okay, water will be chosen and then oxidized become oxygen. So and then 4 mole electrons equal to 4 mole Faraday. produce 1 mole of oxygen. So now, based on previous calculation, 3.731 times 10 to the power of 2 Faraday. So how many mole of oxygen will produce? So here again is stoichiometric calculation. You get 9.326 times 10 to the power of negative 2 mole oxygen. Next, the question asks about volume, right? Volume at room temperature. So you're using the mole over here times 24 dm cube per mole. This is the molar volume. So you get the answer 2.24 times 10 to the power of negative 1 dm cube. You also can use another method, which is PV equal to nRT, and then substitute everything. For PV nRT, must remember, use the right R constant, 0.0206 liter atm per mole per Kelvin. Okay, and then make sure to convert the temperature to Kelvin. So among these two, right, I prefer you use method 1. Now let's discuss for the last PSPM set question 2018-2019. Okay, again this is the original question. This set of question is follow the latest format. So for electrochemistry, total 10 marks. Okay, next. Let's start analyze the question. A galvanic cell is constructed based on the notation below. Again, cell notation is given, so this part is belongs to anode. So this is a division of two different phase of the compound, and then here is the salt bridge. Okay, division of the different phase. Okay, this part is for cathode. So the cell potential is 1.58 volt when concentration of zinc 2 plus and silver plus with this kind of concentration. So meaning that here we are going to use Nernst equation. Calculate the value of X given that the E node cell is positive 1.56 volt. So this is the E node cell, here is the E cell. Okay, part B. A charge of 0.025 Faraday was passed through an aqueous solution of Mn plus using a current of 200 ampere. Okay, so an amount of 0.79 gram of M was deposited at the cathode. So given molar mass 63.2 gram per mole. Okay, normally, right, this Faraday question we need to find the Q equal to IT. But in this case, Q is given, I is given, but T is not given. That's why the question needs us to find the minute for the deposition. Always remember the T that we find from Q equal to IT is in second. So after you find the answer you have to convert become minute. Okay, second part, calculate the volume of oxygen gas liberated, okay, means released at the anode at STP. Just now the question is room temperature. Now this question is STP. STP is 22.4 dm cube per molar. Okay, so let's check how to solve the part A and part B. So for part A, again and again, even though the question didn't ask you to write down the half equation, you also compulsory to write down the anode equation, cathode equation, and combine both and get the overall equation. So based on here, E cell and E node cell is given, and then the N value you have to refer to the equation, 2 electron, and then concentration of product, okay, the zinc 2 plus aqueous over the concentration of the reactant, silver plus to the power of 2, and then the question asks you to find out the X. X means the concentration of zinc 2 plus. So okay, let's summary again the notes, the step for you all to solve this kind of problem. First, write out anode equation, cathode equation, and then combine to get the overall equation. Then you make sure that you get the value of E node cell by using E node cathode minus E node anode, and then make sure you get the value of N that you can check from the equation. What is the number of electron, and then what is the concentration of product and concentration of reactant. Also, you can get from the overall equation before you start substitute. Okay. So this conclusion, X equal to zinc 2 plus equal to this amount of molarity. Always remember, must write down the final unit. So just now is Q equal to IT. Okay, the Q is given, and then I is given, but T is not given. Okay, how to find out the Q? because based on the standard relation, 1 Faraday equivalent to 96,500 coulomb. So now given is 0.025 Faraday. So by stoichiometry calculation, you can get 2412.5 coulomb is equivalent to 0.025 Faraday. So from here, you can find out T value. And the question insists the answer in minutes. So you divide it by 60. So you get the answer 20.104 minutes. Okay, for the second part, right? Okay, you have to write down the N naught equation. As I mentioned just now, water will be chosen and oxidized become will release oxygen atom. So based on here, 4 mole of Faraday or 4 mole of electron is equivalent to 1 mole of oxygen. So based on the information given by the question, the number of Faraday or the number of mole is 0.025. So stoichiometry again, stoichiometric calculation again, you will get 6.25 times 10 to the power of negative 3 mole oxygen. Once success, find out the mole of oxygen, then use times the molar volume at STP because question given in at STP condition. So this is the final answer, 0.14 dm3. So based on the previous 4 years past year question, you will notice actually the question keep on repeating, same pattern. Okay, A, B, C, D, E. The set is A, B, C, D, E. Sometimes ask you to find the A, sometimes ask you to find the C, sometimes ask you to find the A. So you must familiar. Practice make perfect. Try more exercise. Okay, you also can focus about the question that related with the drawing of the galvanic cell, the operation of the galvanic cell as well. Thank you.